Hi students, hari ni kita sambung dengan revision on topic permutation and combination. Take a look at the first question. Okay, now you are given 5 letters and 3 digits, but you need to form a code that consists of 3 letters and 2 digits. So how many codes can be formed if no letter or digit is repeated? So how do you know whether this is a question on permutation or combination? Okay, simple. If you can find the word code or any words with arrangements or any word with no repetition, okay, that will be a question on permutation. Okay, so this question is on permutation because you can find the keyword codes here. Okay, let's find out how many codes can be formed. Okay, since we need 3 letters and 2 digits only, but we are given 5 letters and 3 digits, therefore the codes form will be 5p3. What does this mean? It means there will be 3 letters out of 5 codes given. Okay, and then you must times by 3p2. It means 2 digits chosen out of 3 digits. So when you times that together, you'll get 360 codes formed altogether. Okay, second question. You have a badminton team that consists of 7 students. Okay, but the team will be chosen out of 8 boys and 5 girls. Okay, the number of team that can be formed is such that each team consists of 4 boys. Okay, now questions on permutation or combination. Are there any word codes? Are there any word repetition? There is no codes. There's no word repetition. Therefore, this is a question on combination. Okay, now first part of question. You need 4 boys. The team must consist 4 boys. Okay, is that all? No. Okay, this is not even a team because a team must consist 7 students. So there is only 4 boys and the remaining must be girls. Okay, how many girls? That will be 3 girls. Okay, because altogether it will be 7. So the number of team form will be 8C4. Why 8C4? Because 4 boys is chosen out of 8 boys. And then you times by 5C3. Whereby 3 is the girls chosen out of 5 girls. Okay, when you times that together, you'll get 700 team form. Okay, second part of the question. Okay, the team must consist not more than 2 girls. Okay, what does that mean? Well, it means there will be 7 boys or 6 boys and 1 girl, or 5 boys and 2 girls, but cannot be 3 girls. Not more than 2 girls, meaning you cannot have more than 2 girls. You cannot have 3, you cannot have 4 girls, and so on. So the combination will be 7 boy or 6 boy 1 girl, or 5 boys 2 girls. So how to calculate that? Okay, for the 7 boys, that will be 8C7. Why? Because 7 boys is chosen out of 8 boys. Okay, and second part will be 8C6. Why? Because 6 boys is chosen out of 8 boys, and then you must multiply by 5C1 because 1 girl is chosen out of 5 girls. Okay, and plus 8C5, 5 boys out of 8, and then you multiply by 5C2. So when you times that and add up all together, you'll get 708 ways. Okay, so next question. Okay, you are given 5 letters. Okay, and how many you need? Find the number of possible arrangement in a row of all the cards, meaning you need all letters. Okay, there is a word arrangement, so the keyword shows that this is a question on, yes, correct, permutation. So the first part of the question will be, okay, there are 5 letters, we need all, that will be 5p5 or 5 factorial, which is 120 arrangement. Second part, find the number of this arrangement in which letter E and A are side by side. Okay, this E and A cannot be parted. Okay, they cannot stay in distance. Okay, so how do you calculate that? First, you must consider E and A side by side. Okay, so how many ways can you arrange that? These two E and A. This E and A can be arranged in 2 factorial ways. Okay, whereby this is equivalent to 2. And then you will consider all of them, all arranged all together. So you have EA, we can combine them as one because they cannot be parted. So there will be 1, 2, 3, 4. Okay, spots to be filled up. And therefore there will be 4 factorial ways to arrange these 1, 2, 3, 4 letters. Therefore, the total number of arrangement will be 2, these 2 times dengan 24, okay, which gives you 48 number of arrangements. Okay, fourth question. Again, team. A debating team consists of 5 students. And these 5 students are chosen from 4 monitors and 2 assistant monitors and 6 prefects. Okay. So calculate the number of different ways the team can be formed if there is no restriction at all. Okay, if there is no restriction at all, fine. Okay, in other words, you have to choose 5 out of the total number of students there available. Okay. So in other words, you need to calculate the total number of students available. Okay, let's calculate. Oh yeah, this is a question on combination because there are no codes, no words, repetition, no words arrangement and so on. Okay. Okay. There is no restriction. It means you need to know the total number of students. The total number of students is 12. Okay. 4 plus 2 plus 6 is 12. Now, 5 is chosen out of 12. That will be 12C4. Yes, 12C5, sorry. And that will be 792 ways the team can be formed. Okay, second part. Okay, the team consists only monitor and exactly 3 prefects. Okay, it has fixed there. It has a fixed thing which is exactly 3 prefects. But we need 5 students, and the remaining 2 students must be chosen from the monitor because it says monitors only, no assistant monitor. So the team consists of 3 prefects and 2 monitor. So how do we calculate 3 prefects and 2 monitor? That will be 6C3. 3 prefects is chosen out of 6 prefects and times by 4C2, meaning 2 monitors is chosen out of 4 monitors. Okay, you times that together and you'll get 120. Okay, fifth question. Diagram below shows 7 letter cards. Okay, a 4-letter code is to be formed using these 4 cards. Using 4 of these cards. Okay, find the number of different 4-letter codes that can be formed. Altogether there are 7 cards, but you need 4 letters. Okay, now this is a question on permutation because you can see the word codes there. Okay, so now the code consists of 4 letters, and then that letters is to be chosen out of 7 letters. Okay, so the number of codes formed will be 7P4, which gives you 840 different codes. Yeah? Okay, B. Okay, this is a permutation with condition. Okay, what is the condition? The condition is such that the code must end with a consonant. Okay, now we must consider this first. Consider this condition. Okay, how many consonants are there in these cards? There will be 1, 2, 3 and 4 consonants. Okay, there are 4 consonants, meaning these last letters, this last letter is a consonant, and there will be 4 ways of putting a letter here. Okay, now you have remaining 3 here. Remaining 3, first 3. So what will be this arrangement for these 3 letters? Okay, now before you start, you must remember that 1 letter is chosen out of this. If 1 is and be placed here. Okay, if 1 is chosen, meaning you now have 7 letters left. No, not 7. 6 letters left. Okay, 6 letters left. Okay, so here with these 3 remaining place, that will be 6p3 ways of filling up these letters. Okay, why 6p3? Because 3 letters is chosen out of 6 letters remaining. Okay, and the arrangement will be 6p3 times 4 ways, which gives you 480 codes. Yeah. Okay, 6th question. A coach wants to choose 5 players consisting of 2 boys and 3 girls. And the question is being repeated. To form a badminton team. Okay, you are given 4 boys, 5 girls, but you need 5 players only, which must consist of 2 boys and 3 girls. Okay, now this is a question on combination. Why? Because it doesn't have the word codes or arrangement, sitting arrangement, side by side and so on. So the number of ways can be formed, that will be 4c2, because 2 boys is chosen out of 4 boys. Okay, and then times by 5c3, because 3 girls is chosen out of 5 girls, and you times that together, you'll get 60. Okay, B. 5 players arranged in a row. Nampak? There is another keyword here in the question itself. Arrange in a row. So this is a question on permutation. Because why? Arrangement is important in this case. Okay, they want to take a photograph. They must be arranged in order, and there is one condition, which is 3 girls must sit next to each other. They cannot be parted. Okay, so how to arrange that? First thing, we must calculate the number of ways to arrange the 3 girls that sits next to each other. So these 3 girls here, for these 3 girls here, there will be 3 factorial ways of arranging them. Okay, and there are 2 remaining here. These 2 remaining places are the boys, isn't it? Okay, because one team consists of 2 boys and 3 girls. Okay, so these must be the boys. Okay, now consider this as one place. So 1, 2, 3, you have 3 sitting places to be arranged. Therefore, the arrangement of this is 3 factorial. And the total arrangement will be 3 factorial times by 3 factorial, which gives you 36 sitting arrangement.